Tonight's homework assignment comes from page 402, and we are still working with inequalities. On number 38, what we are needing to do is to set up an inequality and then solve it. I'm going to graph it and check it. Number 38 is a word problem, though, so what we're going to do is to read one or two words at a time and write out what it's saying. So number 38 says 2/3, so I'm going to write out the number 2/3. When we see the word of, anytime we see the word of, it means to multiply. So 2/3 times a number. Well, we don't know what the number is, so we'll just pick a variable to use. I'll just use n. So 2/3 times n decreased by. Well, decreased by means that we're going to subtract, so minus. Decreased by 27, so minus 27. Is at least. When we see the words at least, that means it, or at least 9, it can mean it can be 9 or it can be more than 9. So it needs to be greater than or equal to 9. We can clean this left side up a little bit and think of 2/3 n, or 2/3 times n as just 2/3 n minus 27 is greater than or equal to 9. And then we can solve that by adding 27 to the left and adding 27 to the right, because if we subtract 27 and add 27, those give us 0. So on the left-hand side, we'll have 2/3 n. On the right-hand side, we're going to add those together and get 36. Since all we did was add 27, we don't need to do anything with the sign except for bring it down. 2/3 n is greater than or equal to 36. Well, since since n has been multiplied by 2/3, our final step in solving this inequality is to divide the left by 2/3 and divide the right by 2/3. 2/3 divided by itself gives us 1, so just n on the left-hand side of the inequality. On the right-hand side of the inequality, if we divide 36 by 2/3, be sure that you put the parentheses around any type of fraction that you're going to enter into the calculator. Well, if we divide those without a calculator, that would be like 36 times 3/2. We could simplify the 36 and the 2 to make 18 and 1, and then if we multiply 18 by 3, we would get 54. So n is on the left side, 54 on the right side. Since we divided by a positive number, our sign is going to stay exactly like it was. So n is greater than or equal to 54. If we put that in set builder notation, it's going to look like this. And we're just going to have whatever variable we see present in the problem at the front with a bar. And we would read that as n such that n is greater than or equal to 54. That means any number that is either 54 or greater than 54 will make this inequality true. Well, our next step is we're going to put that on a number line. We're just going to graph the solution. We don't, obviously in this problem, don't have to number our number line all the way from 0 to 54. I'm just going to make a single mark and label it with a 54. Since we have that the solution set is n is greater than or equal to 54, we're going to have a closed dot on 54 because 54 is included in that set, so we need to fill it in. And then we need to shade all of the numbers that are greater than 54. The numbers that are greater than 54 are located to the right of 54 on a number line, so they would look, so our graph would look like this. So all of the numbers that are to the left of, or to the right of 54 on a number line make the inequality true. So let's just pick one of those numbers. You can pick any number that is greater than or equal to 54. Well, since it says greater than or equal to 54, let's use 54. I'll do 2/3 instead of times n. I'll do 2/3 times 54 minus 27 is greater than or equal to 9. Well, if we simplify the left-hand side of this inequality, 2/3 times 54, well, that's going to give us 2/3 of 54 is going to be 36. 36 minus 27 is greater than or equal to 9. If we continue to simplify, 36 minus 27 is 9. Is 9 greater than or equal to 9? It is. 9 is equal to 9. So we know that we worked that correctly. So our solution is located on the left. This is the graph of the solution, and this is us checking our solution. On number 39, we're going to have the same instructions. It says 3 times the sum of a number and 7. Well, 3 times the sum of a number and 7. Well, if I want to do the sum of a number and 7, that's going to be n plus 7. But since we're multiplying that entire sum by 3, I need to put the n plus 7 in parentheses. Then I see the words is greater than. So greater than symbol, we don't want greater than or equal to, so don't put the line underneath the greater than sign. So is greater than 5 times the number 5n less 13. Less means that we're going to subtract, so minus 13. So don't be confused between less and less than. If we have less 13, that just means minus 13. If it says 5 times the number less than 13, then our expression on the right-hand side of the inequality would be reversed. We would have 13 minus 5n. At this point, our first step in solving that inequality is to use the distributive property to get rid of the parentheses on the left-hand side. 3 times n is 3n. 3 times 7 is 21. Since they're added inside the parentheses, we're going to add them after we've used the distributive property. On the right-hand side of the inequality, there aren't any parentheses, so we'll just bring down the expression on the right-hand side of the inequality. At this point, we said that we would combine any terms that are like terms on the left-hand side or the right-hand side. There are no like terms on the left-hand side, and there are no like terms on the right-hand side. So our next step, as we said, if we have a variable term on each side of the equal sign, we need to choose one of those to get rid of. I'll just get rid of the smaller one on the left-hand side. Subtract 3n from the left and subtract 3n from the right. 3n minus itself gives us 0. So on the left-hand side of the inequality, we're left with just 21. On the right-hand side of the inequality, 5n minus 3n is 2n. So 2n minus 13. Since all we're doing is subtracting 3n, we don't need to flip the sign. Again, only if we multiply or divide by a negative are we going to change the symbol that comes between. At this point, this is a two-step inequality that we need to solve. 2n minus 13 is on the right side, so what we need to do is to get rid of the minus 13 by doing the inverse operation of subtracting 13, which is adding 13. If I add 13 to the right, we also need to add 13 to the left-hand side. Minus 13 and plus 13, like we said a minute ago, cancel. On the right-hand side of the inequality, we have 2n. On the left-hand side, 21 plus 13 is going to give us 34. Since we just added, again, we didn't multiply or divide by a negative, our greater than sign stays as a greater than sign. At that point, we're one step away from solving the inequality. Since we have 2 times n, we need to divide the right by 2 and divide the left by 2. 2 divided by itself gives us 1. So 1 times n, or just n, on the left-hand side. 34 divided by 2 is 17. So the greater than symbol stays greater than because all we did is divided by a positive 2. When we put this solution in set notation, we're going to put brackets on either side. We're going to take our variable that we see, which is n, put our bar, and then with set builder notation, we need to put our variable in front, so where the 17 is, and we need to put our 17 where the n is. So to do that, we're going to need to change the sign. So 17 is greater than n. Well, that's the same thing as n is less than 17. And what that means is that any number that is less than 17 will make the inequality true, meaning it'll make the left-hand side of the inequality greater than the right-hand side. So if we want to put that on a graph, if we need to graph the solution, I'm going to put it on a number line. I'm going to just find the number we see in our solution set, which is 17. I'm going to mark our number line and label it with a 17. We know that n has to be less than 17. It can't be equal to 17, so that tells us that we need an open circle on 17. And then we're going to shade everything that's less than 17, so that'll be everything to the left of 17 on the number line. Be sure to put an arrow that tells us that all of the numbers that go on in that direction forever are going to make that inequality true. So our graph would look something like that. If we wanted to check that solution, what we can do is to take the original inequality, choose a number that is part of the solution set. Again, that just means any number, in this case, that is less than 17, and put it back in place of the variable everywhere we see the variable. So here and here. Well, all numbers less than 17, so I'll use 16. So instead of 3 times n plus 7, we'll have 3 times 16 plus 7. And instead of 5 times n, we'll have 5 times 16. And then we'll simplify using the order of operations. Well, 16 plus 7 gives us 23. 23 times 3 is greater than 5 times 16. Well, that would be 50 plus 30, so 80. 80 minus 13. If we continue to simplify, let's do the right-hand side. 80 minus 13 gives us 67. And on the left-hand side, when we multiply 3 times 23, well, what do we come up with? 3 times 23, that's 20, 40, 69. So is 69 greater than 67? It is. So this is a little bit different in the way that we check an equation. On the equation, we always need the left-hand side to equal the right-hand side. When we're checking an inequality, we don't necessarily want the left-hand side to equal the right-hand side. We want for it to compare to the right-hand side with whatever symbol we see in the middle. So in this case, 69 is greater than 17. So we want to show that the left-hand side is greater than the right-hand side. So that's number 39. If you look at number 48, number 48 says the admission fee to a video game arcade is $1.25 per person, and it costs 50 cents for each game played. So we said a minute ago that anytime we see the word each or per, we're going to be thinking about multiplying. So LaToya and Donetta have a total of $10 to spend. What is the greatest number of games they will be able to play? Well, in class today we talked about, before we start plugging numbers into an inequality, I'm going to kind of write out in words what we want for our inequality to say. We know that we have a limited amount of money, $10 to spend. So we want to spend as much money as we can, so I'm going to say that we want the money that we want to spend to be, well, it has to be less than $10 or equal to $10. So the money that we want to spend is less than or equal to $10. This money that we're going to spend, we know that if we enter that arcade, we have to pay $1.25. So it's going to be made up of a $1.25 charge just to enter the arcade, the admission fee, and 50 cents per game. So when we hear the word each game or per game, again, that means 50 cents times the number of games played. So I'll use G to represent games played. So plus, because we're paying the $1.25 and we're paying 50 cents times the number of games we played, and we know that we need for that to be less than or equal to $10. At this point, we have a two-step inequality to solve. I'll subtract $1.25 from the left and from the right. $1.25 minus itself gives us 0, so on the left-hand side of the inequality, all that we're left with is 0.50G, or 50 cents times the number of games. On the right-hand side of the inequality, when we subtract, we're going to get $8.75. At this point, we want to divide the left-hand side by 0.50. We want to divide the right-hand side by 0.50. 0.50 divided by itself cancels. So what we have on the left-hand side is G. On the right-hand side, we need to divide those two numbers. And when we do that, we're going to come up with 17.5. So 17.5 games. Well, we know that if we have to put the full amount of money, 50 cents, into a machine to be able to play a game. So it's impossible to play 17.5 games. So really the most games that we will be able to play in this situation is 17. Because again, it says less than or equal to 17.5 games. We can't play half a game. We can only play the 17 full games. So 17 is the most games that we would be able to play on number 48. Looking at the next two problems, we don't have any words to deal with in this. All we're needing to do is to solve the inequality. So if we want to solve the inequality on number 52, since we see a variable term on each side of the inequality, I want to get rid of one of those. It doesn't matter which one. I'll get rid of the smaller one on the right-hand side. So since we see plus r, I'll subtract r from the right, subtract r from the left. R minus r gives us 0. So on the left-hand side of the inequality, when we simplify, we get 2r minus r. That's just r. So r minus 2.1 is less than negative 8.7. Again, since we just subtracted something, we don't have to flip the sign. At this point, we're still wanting to get r by itself, so our next step and final step will be to add 2.1 to the left and add 2.1 to the right. 2.1 subtracted from itself gives us 0, so what we end up with on the left-hand side is r. On the right-hand side, we need to add those two numbers, and when we do that, we're going to get 6.6, negative 6.6. So since we had a less than sign and all we did was add, then what we're going to do is just keep our sign the same. So r is less than 6.6. If we put that in set notation, then our solution set is going to look like this. On number 53, it's very similar. We have 7 minus 2y is less than negative y minus 3. We have variable terms on each side, so we need to get rid of one or the other. I'll get rid of the one on the right-hand side on this problem. Since we have minus y, I'll add y to the right and add y to the left. Minus y plus y, those cancel. So on the left, we end up with 7 minus y, that's minus 1y because we had negative 2 plus 1, is less than negative 3. We want to get rid of the 7. Don't be confused into thinking that since we have a minus, we need to add 7. We want to make that 7 equals 0, so we need to subtract 7 from the left and subtract 7 from the right. 7 minus 7 equals 0, so on the left-hand side, we end up with negative y. On the right-hand side, we end up with negative 10. Well, we don't want to know what negative y is equal to. We want to know what y is actually less than. So we want to know what y is less than. So we can think of negative y as negative 1y, so we can divide the left by negative 1 and divide the right by negative 1 since y is multiplied by negative 1. Once we've done that on the left-hand side, the negative 1's cancel and we end up with just y. On the right-hand side, we get positive 10. And since we divided by negative on that problem, we need to flip the sign from less than to greater than. That means any number that is greater than 10 should make this inequality true. Let's put that in set notation, and it's going to look like this. So let's pick a number that's greater than 10. Let's use 11 and check our solution. 7 minus 2y is less than negative y minus 3. Let's use 11. So instead of 7 minus 2y, we're going to have 7 minus 2 times 11. And we want to see if that is less than negative y, so negative 11 minus 3. Well, on the left-hand side, 7 minus 2 times 11, we'll write that as 7 minus 22. 7 minus 22 gives us negative 15. On the right-hand side, negative 11 minus 3 is negative 14. Well, is negative 15 less than negative 14? It is, so we know that we probably worked that problem correctly.